Hello, I'm Gauri Krishna. I'm a BTech third year student in Computer Science and Engineering at Karani University. So today we will see the fourth experiment in data science and ecosystem lab, which is statistical inference. So we'll see the points. So this is a fourth experiment, which is statistical inference. So there are basically 10 questions are there in this. So the first question is filtering the female entries and sampling mean for n equal to 500. Load the CSV data set of supermarket data. So I've loaded the CSV file called supermarket, and here. Uh, Yeah, here it filters only it includes the rows where gender equal to female, and it randomly takes a sample of 500 rows from the female data, and it calculates the average unit price for that sample, and then it prints the sample mean for that 500 females. So the sample mean for n equal to, that means 500 equal to, this is the answer we got, and this is the output. Second question is sample and compute mean. Sampling mean for here sampling mean for n equal to 1000. Uh, it is basically like it's similar to task question one, and but it takes 1000. There it was 500. Here it is 1000 random female records. So it calculates and prints the average unit price for that larger sample. It allows a comparison of means for different sample sizes. So this is the output, sample mean for n equal to 1000. This is the answer. The third question is calculating population mean uses all female entries in the data set. Like basically here, no sampling. It calculates the mean of unit price across the entire population, and it serves as a baseline to compare sample means against. And this is the output for the third question, population mean. Total population mean is this. This is the answer. And the fourth question is 95 percentage. Uh, yeah, the 95 percentage confidence interval for sample mean n equal to 500. It takes a 500 record female sample. It calculates the sample mean and sample standard deviation. It uses the z-score value, which is 1.96. You can see, which is to compute the margin of error, and it constructs the uh, confidence interval around the mean, which is CI. So it checks whether the true population means lies inside that CI, and it prints the output like 95 percentage confidence interval equal to. This is the answer. Population mean. Does population mean lie in CI? That's what the question. So it is true. So it prints. So this is the fourth one, and this is the fifth one. And fifth one, we'll see the 99 percentage confidence interval for sample mean n equal to 500. Was it is like similar task of it is similar to the question 4, but it uses this at there we used 1.96 as a set score value, but here we used the set score value as 2.567 so for 99 percentage confidence. So the CI is wider because higher confidence level requires more certainty. So this is the output, 99 percentage confidence interval equal to np dot float. This is the value. Then again np dot float. Sorry. This is the value. So and then this is the sixth question, which is confidence interval coverage in 25 trials. it runs 25 independent samples where n equal to 500 and z equal to 1.96. For each trial, it computes the sample mean, standard deviation, and the 95 percentage CI. So it counts how many trials of CI contained the true mean, and it demonstrates the coverage probability of 95 percentage CIs. And this is the code. Here we can see the 25 trials of, we have given 25 trials. So that's why we got 25 trials here in the output. So this is the output. It contains population mean all are true, not first the fourth one is false. It's showing false and all the other is true. So out of 25 trials, 24 are CIs contain the population mean. One is false. So based on this table, our seventh question is based on this table. So yeah, it's person correlation hand was weight. So it creates a small data sets of hand, length and height for 5 people. We are given 5% like A, B, C, D and the hand, then height, their height. And it computes person's correlation coefficient. It measures the linear relationship between two variables. So here the Poisson correlation is based on this data we've given. It prints the output like this. And then the eighth question. Eighth question is also based on the table. It's a Spearman correlation, hand was height, same. It uses the same data set we've used in this seventh question, which is basically this table. So yeah, computes the Spearman correlation measures rank-based relationship. It is useful when data may not follow a straight line trend. So this is the output for that. And then the ninth question, it's it's based on this data height, score, and age. Based on this data set, we have created the ninth question, which is covariance and correlation matrices. It creates a data set with height, score, and age, as we have given here. It creates height, score, and age. Then it computes the covariance matrix. It shows how pairs of variables vary together. And it computes correlation matrix, standardizes the relationship strength between variables to a range from -1 to 1. So this is the output. This is the covariance matrix and this is the correlation matrix. So this is the these are the two metrics in the output. And the last question, 10th one, which is basically it's a one-tailed z-test for weight gain. Here, given non-population mean the population standard deviation, sample mean, and sample size. So it calculates the Z score to test if the sample mean is significantly greater than the population mean. That's why Z score equal to sample mean minus population mean. We should know if the population standard deviation, sample mean is significantly greater than the population mean. So it compares the Z score with critical Z value for 5% significance. It's one tail. Um, and it decides whether to reject or whether to reject the null or fail or to reject the null hypothesis. So here, this is the output. Calculated Z score is 1.289, then Z critical value is 1.645, and failed to reject the null hypothesis. It is showing that not enough evidence to support the claim. So it is failed to reject the null hypothesis. So this is the 10 questions. These are the 10 questions in experiment number 4. So yeah, that's it. So this is all about experiment number 4. Thank you.